Okay, so this is the second module for wireless ad hoc networks. So here in the first module we have already seen that there are different challenges that have to be overcome in order to implement and deploy these kind of networks, the ad hoc networks. These indeed are very attractive, but at the same time the challenges are also huge. So what are the different challenges that we'll see over all the different lectures on ad hoc networks? But now for the next few moments we are going to go through some of the other challenges that are involved in deploying these networks. We are going to look at them at high level, and then in the next lectures we are going to go through them in more detail. So the first one is medium access. So as you know that medium access is a property in the second layer, is a function in the second layer, which is the link layer of the OSI stack. And the medium access is all about that you have a collection of different nodes, and these nodes they share the same medium, and how one can one can offer access to these different nodes in a fair manner is what medium access control is all about. Now there are different protocols that have been proposed for medium access control in different wired and wireless networks, but these are not very usable these are not very useful in these kind of ad hoc networks, because what is required is to offer distributed access. It is required in these networks to offer distributed access to the common channel. So the channel is one, and in that particular channel there is a single channel, and in this particular channel distributed access has to be offered. So the traditional MAC protocols that one is familiar of, basically they do not deal with this kind of problem. Additionally, there is problem of host mobility in MANETs, which are also not dealt with in the traditional MAC protocols. And additionally, what we have is an environment where there is no centralized coordinator. So consequently, if there is no centralized coordinator, the traditional schemes such as the TDMA, time division multiple access, or frequency division multiple access, FDMA, these are schemes which are not very suitable for implementing in these kind of networks, because if there is no centralized coordinator, a designated one which can help in polling and in offering different time slots or frequencies to the different the different nodes. So who is going to take care of this? Because we do not have such an entity, there is no centralized coordinator. And additionally, there are issues called the hidden terminal problem and exposed terminal problems, which basically haunt these kind of networks. So so there are multiple problems of medium access in these networks. Let us now talk about energy efficiency, a very important issue when it comes to ad hoc networks. As I said in module 1, that these networks, the nodes in these networks, the nodes in ad hoc networks, they are battery powered. So there is no infinite battery that powers these nodes, and it is very limited. So typically, once the battery is fully charged, it can be from it can last, the batteries can last for couple of minutes to to couple of hours, right? So a couple of hours at the most. So that is the maximum that a fully charged battery in these networks used in these nodes in these networks, they can last for. So there are different there are different ways in which energy has to be considered. So energy is consumed due to transmission, due to computation, retransmission by the different nodes, the intermediate nodes who retransmit the packets that it receives, retransmission and reception of nodes. So all of these, computation, communication, reception, transmission, retransmission, all of these things, these tasks they consume power or energy. Now, at the same time, we have seen that the batteries, they have very limited life cycle. They can operate, once fully charged, they will not be able to last for too long. So, additionally, there are other issues with these batteries. They have very they have very high discharge rate. Typically, the current day average batteries that are used in these ad hoc networks, these have very high discharge rate, low life cycle, and so on and so forth. So, what is required is, for use in the nodes of these networks, it is required to have high performance and smart batteries, and which will support mobility of the devices also. That means the mobile, which can be used in the mobile devices. And these batteries should have low self discharge rate, they should have long life cycle, they should be able to be they should be able to operate in wide temperature ranges, and they should have high energy density. So, the commonly used batteries in these the different nodes of these networks include the nickel cadmium, NiCd, NiMH, nickel metal hydride, lithium ion. Lithium ion is more common, lithium ion batteries. And so, because the energy is very scarce in the different nodes of these networks, what is required is to take care of energy, manage the energy at all levels of these networks, be it at the device level, the different protocols that are designed for these networks, or the different applications that are designed for use in these networks. At all different levels, energy management is a very crucial issue. Now, one thing you might have already observed, that we are using the term energy and power in an interchangeable manner. So, as you are probably aware that energy and power, they are inversely related. So, sorry, I'm sorry, energy and power. So, power is basically energy consumed per unit time. So this is how energy and power are related, and so that is why we often interchangeably use these two terms. So, next is cooperation. Next issue is cooperation in wireless ad hoc networks. This is a very important issue. That is typical of ad hoc networks, because what we have is a multi-hop scenario, source node sending to the destination node, and this is something that we have already seen. Source node sending the data to the destination node. The destination node is not within the direct transmission range of the source node. So, there are intermediate nodes which will act as relays for the data that is sent by the source node to be delivered to the intended destination node. So, we have these intermediate nodes which are acting as relays. So, quite understandably, quite obviously, these nodes, they have to cooperate. The intermediate relays would have to cooperate with the source and the destination node for the data transmission to be successfully completed. And at the same time, these nodes, as we have already seen, all these nodes, the relay nodes indeed, are very much energy constrained. So, naturally what happens, like in a social network, that means a network of human beings, for example, when there is scarcity of resources, there is an issue of cooperativeness. Some nodes may or may not be willing to cooperate. So, this sort of thing is typical of ad hoc networks. So, there are two extremities that is encountered with respect to cooperation in ad hoc networks. One is the case of total cooperation. So, if all the relay requests are accepted, then we have the case of total cooperation. That means the nodes, they cooperate fully, and that is not a very good thing, because the nodes, they themselves have very limited energy, and if they relate all the requests that are that are sent to them, then they are going to be they are going to exhaust of their energy quite fast. And we have the case of total non cooperation on the other extremity, where none of the relay requests that are sent to a particular node are accepted by it. So, any packet that is sent to the node would be dropped by that particular node. So, the network throughput in such a case is going to go down quite rapidly. That means the network is not going to function for too long. So, neither of these two extremities, that means the extremity of total cooperation or the extremity of total non cooperation, is ideal for implementing in these networks. So, there are additional issues with respect to cooperation. because of the above things that I just mentioned, issues of selfishness, then self-interest, symbiotic dependence. That means the nodes ideally would like to symbiotically depend on each other. So, if one node basically helps another node in relaying its packets, though it would also expect that the other node is also going to help it in relaying. So, there is some kind of mutual dependence, symbiotic dependence that is basically typified in these between the different nodes in these networks. Okay. So, these networks, because cooperation is a very important issue, these networks have nodes which have a tendency to misbehave. So, one of the first works, on misbehavior in manates was done by a group of scientists, Marty and others, and it was published in a paper in ACM Mobicom in 2000. So, in their work, in Marty et al.'s work, they basically defined the misbehaving nodes to be the ones which agree to cooperate, but eventually which do not. Right. So, initially they would agree to cooperate with the other nodes, but eventually when it comes to actually cooperating, they do not. So, what is important is to intelligently identify the misbehaving nodes and avoid relaying through these nodes. This is what basically is important, that is, this is basically a fundamental thing that has to be implemented, and this is what was proposed by Marty et al. In their particular work. So, in their proposed solution, they have their solution to this particular problem has two components. The one component is known as the watchdog, which basically runs on every node to keep track of the behavior of the other nodes in the network, and the other one is the path rater, which basically uses the watchdog information to find out the reliable routes. So, watchdog is keeping an eye on the behavior or the misbehavior of the different nodes in the network, whereas the path rater, based on the observations of the watchdogs, the path rater is determining that which routes are the reliable ones. That means, which nodes in the different routes would help the packets to be delivered successfully to the intended destination node. So, there were different other works with respect to cooperation, works on offering incentives for cooperation. A bunch of European scientists, Batian and Huboy, in the year 2000-2001, they published a couple of works in Mobihawk and IEEE Communications magazine, where they suggest providing incentives for cooperation without overloading the network. So, what they proposed is some kind of a reward penalty model. In this particular model, the nodes that are receiving a service are charged, and the nodes which are providing the service, they are remunerated. Okay. And based on this particular model, the different relay requests at the nodes, they are either accepted or rejected. So, the drawback of such a model is that there is large overhead that is involved in implementing such a model or such a solution, and that is not very good in resource constrained networks, the ad hoc networks and sensor networks alike. One of the ways of handling the issue of cooperation is to promote reputation, keeping track of reputation of the behavior of the different nodes in the network. So, reputation means that how the different nodes are behaving. So, that means that if a particular node is sent a packet, keeping track that whether it is forwarding it or it is dropping it in between. So, keeping track of this thing is a very important thing, and how one keeps track of the reputation of the different. So, if a node basically drops the packet, that means it is not a node which is reliable. So, its reputation level is going to go down, and if a node forwards, then its reputation level is going to go up. And at the same time, it is also important to identify and track the liars in these networks. Which nodes are liars. That means that the nodes which are believed to be able to cooperate, but which basically do not cooperate much, they are not much cooperative. Okay. So, these are termed as the liars. There are security challenges in cooperation as well, because ideally cooperation is very good, it is an open medium, which is shared by different nodes. The same medium is shared by different nodes, and these nodes, they dynamically change positions. At the same time, there is no centralized network management or certification authority, and at the same time, because it's an open medium, any node can get into the network and can be malicious and can hurt the functioning of any of the existing nodes in the network. So, these nodes are prone to attacks, infiltration, eavesdropping, interference, so on and so forth, all these different types of common attacks. The main problem is that with the existing solutions, one could have handled these problems, because there are well known solutions how to handle attacks, infiltration, eavesdropping, etc., etc. But here we cannot assume that we will have a server, which basically a server or a centralized authority, which can keep track of the behavior and which can help in preventing these attacks. So, such a thing is not possible in these networks, the ad hoc networks. Okay. And on top of that, if a node is cooperating with the other nodes, it might so happen that it can fall victim from a malicious node, because a malicious node can take advantage of the cooperating node. It can send number of continuously it can stream different data, and this good node, the cooperative node, it is going to soon run out of its existing limited resources, energy, etc., etc. So, it is very easy to launch a denial of service kind of attack in these cooperative networked environments. There are some routing challenges as well, because so not only that we have a multi-hop kind of scenario, but at the same time we also have an environment which has high rate of consumption of power at the different nodes, which has low bandwidth, high error rates, because the environment is such that there is high error rate, and so what we have are the nodes that randomly they move from one point to another and so on. So, routing becomes a very important challenge, and secured routing, privacy aware routing are other different routing challenges that are very important considerations in these networks. So, when we talk about routing in ad hoc networks, let me just give you a very high level overview of what are the different routing solutions that are proposed for ad hoc networks. For use in ad hoc networks, there are two main classes. There are a few others also. So, we will talk about now two main classes of routing protocols that are proposed for ad hoc networks. So, one is called the proactive routing protocols or periodic routing protocols. Sometimes these are also known as table based routing protocols. So, the traditional wired routing protocols, for example OSPF, which are table based, belong to this particular category. So, these protocols, they maintain consistent up to date routing information of the whole network. Okay. And examples, so that means that at every node in the network the routing information is stored, and these tables are updated periodically. Okay. So, examples of these networks are the DSDV protocol, the WRP protocol, GSR, FSR, and so on and so on. There are many more ad hoc network routing protocols belonging to this particular category that has been proposed in the literature. The other category of ad hoc network routing protocols is called the on demand or reactive routing protocols. So, as this name suggests, that whenever there is a demand, the source node basically initiates route exploration, discovery of route. That means the source node, whenever it has to send some data, and that it is not able to find the route to the intended destination node, it is going to start the route discovery process. So, these solutions basically, unlike the previous category which were table based, here basically there are these different nodes in these networks, they do not maintain the routing information like in the previous category. So, the routes are created only on demand by the source node, and so typically there is a 3-phase kind of approach that is used in any kind of or most of the kinds of on demand reactive routing protocols. It first starts with the route discovery process, phase, route discovery phase. Then comes the route maintenance phase. That means the routes are once discovered, they are maintained until the route is no longer required. And finally, when the route is no longer required, there is the tear down phase. That means the route is torn down. So these are better in ad hoc networks. These reactive routing protocols, they are better in ad hoc networks as they are resource limited and the nodes are mobile. So because the nodes are mobile, because the resource is very limited, so it is very important to to track the mobility of the nodes in the network and discover the routes whenever it is required, because it is quite unlikely that in a very mobile environment the existing topology information is going to stay intact over time. So the topology information gets changed over time, and consequently it is better to discover the routes in these networks. But keeping in mind this particular advantage, we also should understand that when we talk about ad hoc networks, it is not that all the time the topology is going to be made and broken quite fast in these networks. There are some networks where the topology may not be changing quite fast. In such a case, every time discovering the route, maintaining etc., as in a reactive routing protocol may not be a very good approach. So in such cases, maybe that using the proactive approach, that means the table based approach, would be a better solution. So probably that in such a situation, it might be better or it might be efficient to use the proactive routing protocols. Reactive routing protocols are, on the other hand, as I just mentioned, would be more efficient when we are using them in networks where the nodes are changing their positions quite fast. That means the nodes are quite mobile, and it is important to keep track of the mobility of the different nodes, and based on that, not keep track of the mobility of the nodes. It is difficult to keep track of the mobility of the nodes, and so accordingly find the different routes in the network. So some of the examples of ad hoc routing protocols belonging to the reactive category are the DSR, dynamic source routing, associativity based routing, ABR. AODV is a very popular protocol, ad hoc on demand distance vector routing protocol, and power aware routing protocol, PAR. So like in the proactive category, there are many more types of routing protocols belonging to this category that has been proposed in the literature. Another very important issue is fault tolerant routing, which is something that I have worked on in my research before. So this has been one of my research papers. This led to one of my research papers that was published in the Telecommunication Systems Journal. So here we talk about that faults are quite common in MANETs. So that is something that we have seen, and packet drops result due to faults. Faults could arise because maybe two nodes which were in the proximity of each other, they are no longer in the proximity. So maybe when one node moves and consequently the packet is dropped in between, or there could be different other reasons why faults could develop between different nodes in the network. So there could be problems in the link, that means failure in the link, there could be faults in the node, and so on. So we basically proposed a fault tolerant solution to this particular problem. So the fault tolerant routing problem, it basically says that in the presence of fault, how to efficiently route packets. So faults are inevitable in ad hoc networks. So in the presence of faults, how to route packets. So one of the before our work, one of the previous works was the E2FT algorithm, end-to-end fault tolerant routing algorithm. This algorithm basically involves two major phases. One is called the route estimation phase, the other one is the route selection phase. In the route estimation phase, as the name suggests, what is required is to estimate the packet delivery probability of all the routes at the disposal at any time instant. So you have number of possible routes. So what is required between a source and destination pair? So what is required is to estimate, probabilistically estimate the packet delivery probability. That means the probability of packet delivery through each of these different options, each of these different routes. After that estimate is obtained, then what the E2FT algorithm does is it selects one of these routes that have confirmed to have satisfied a certain optimization constraint, a particular threshold, let us say a particular threshold. When it crosses that threshold, so that particular route is selected, and the other possible routes are basically dropped and are not made available for routing. So, our algorithm that we proposed was, as I told you, it was published in the Telecommunication Systems Journal by Springer, and it is known as the WEFTR, weak estimation based FTR, fault tolerant routing algorithm. So, here also we have the route estimation and the route selection phase, but the way we estimate the packet delivery probability through each of these different alternatives that we have seen in the E2FT algorithm, so that basically does not exist. So we have improved upon that. We have proposed a weak estimation based learning mechanism for estimating the probability of delivering packets through the different routes. So this is the improvement that we have done over the E2FT algorithm. And here is a comparison of performance with respect to criteria such as the percentage of delivered packets, the overhead, etc. And we have seen that the proposed algorithm performs better with respect to that means that it has lower overhead and higher packet delivery probability. That means that there is better probability of delivering packets to the intended destination by using the WEFTR algorithm. So, what we talked about is unicast routing. Now, what about multicast? So, we have, as we have seen in minutes, we have an environment where the topology changes quite fast. We have frequent changes in the network topology, and the nodes, they move on the fly, connections are made and broken on the fly, and so on. And at the same time, we cannot assume the existence of a centralized coordinator like a base station or a mobile repeater. So, the traditional approaches to multicasting, which are typically based on forming and maintaining trees known as multicast trees, are not quite useful in these environments. So, protocols have to be proposed, new protocols have to be proposed, which will be highly adaptive to be able to cope with the high degrees of dynamism that is typical of these environments. So, there are different classes of multicast routing algorithms that have been proposed. We will talk about these in detail later on. So, broadly they can be classified as flooding algorithms or source based tree algorithms, core based multicast routing, and group based multicast routing. So, these are some of the different categories of multicast routing algorithms that have been proposed purely for use in ad hoc networks. Flooding algorithms are like other flooding algorithms that you might be familiar with if you have taken a networks course before. So, where basically the packets, the multicast packets are basically flooded globally in the network. So, so that this sort of approach is good if the environment itself is highly mobile. That means the nodes are moving quite fast. However, it leads to wasted bandwidth due to unnecessary forwarding of duplicate data, and that is also not a quite good thing for use in ad hoc networks, because we have a very limited resource constrained environment, and that is not very good. But at the same time, if the nodes are moving quite fast, you do not have any other option but to go for a naive flooding based approach. Source based multicast tree. So, here multicast trees are established and maintained for each multicast source node in each multicast group. So, if we have G number of multicast groups and S number of source nodes in each group, so what is required is to have it is required to maintain G times S number of multicast trees, and that is not a very good thing, because that will lead to a solution which is not very scalable. So, that means that if the number of nodes increase, if the number of multicast groups increase, or the number of source nodes per group increases, so it will lead to a very not a very elegant solution in these networks. Examples of this include different multicast source based multicast tree approach protocols include the DVMRP protocol, MOSPF protocol, and so on. core based tree basically, what is done is what it does is it creates and maintains a single shared tree connecting different multicast group members. Okay, so that is the approach that is adopted in the core based multicast trees, and this is a very this is a better solution than the SBTs, that means the source based trees, but at the same time this also had disadvantages because traffic is concentrated in these solutions on the shared links only, and that can often lead to congestion in these shared links. Multicast mesh is another one where a node can have multiple parents, and a mesh is formed spanning all multicast group members, and it is good in terms of ensuring reliability, but it is bad, it is disadvantageous because there is unnecessary forwarding of multicast packets along all the redundant paths. Example of multicast mesh routing protocol for ad hoc networks is the CAMP protocol, which is the full form of which is the core assisted mesh network protocol. And finally, the group based multicast forwarding, where a group of multicast forwarding nodes is maintained for each multicast group. Only the forwarding nodes are responsible for forwarding the packets. Processing at other nodes is simplified. All received multicast packets that are not duplicated and rebroadcasted by the forwarding nodes to the all received multicast packets are not duplicated and are rebroadcast by the forwarding nodes to their neighbors. And example of group based multicast forwarding include on demand multicast routing protocol ODMRP and the location based multicast routing protocol. And a few other important issues in ad hoc networks. Power is an important issue that we have already seen. So what is required is not only at the protocol level, not only at the algorithmic level, it is also required to have devices manage the power, right. So there are different device power management techniques that have been proposed. APM is one, ACPI is another. APM stands for Advanced Power Management, which basically comes with a comprehensive power management scheme at individual device level of the mobile computing devices, and which defines a hardware independent software solution. ACPI is also quite similar, so we will talk about this later, but just at the cursory level, this is what device power management does. Protocol power management is required. Protocol, at all different layers, the different protocols that are proposed in the in the protocol architecture, they they all have to ensure that they consume very less power. There should be reduction in the data link layer, reduction in power consumption in the data link layer. There should be reduction in power consumption at the network layer, at the transport layer, and so on. Okay, so these are the different things that have to be taken care of at the different layers. So one other important thing is that we have talked about routing. On top of routing is the transport layer protocol. Common transport layer protocol that is used in the internet is the transmission control protocol, TCP, and as we know that in TCP there is some kind of a handshaking that goes on between the sender and the receiver, right. So basically segments are sent from the sender and in a sequence, and these segments in the sequence they are supposed to be received at the receiver, intended receiver. But it might so happen that some of these segments can be lost in between, and these lost segments have to be retransmitted. So there are different other issues that are associated, which are like control of flow of these segments between the intended between the transmitter and the receiver. So flow control, congestion control, that means that if the receiver is receiving at a rate which is more than how it can handle, or the rate at which it can handle, then what is going to happen is that at the receiver end there will be congestion, and consequently there will be packet drops. So that is undesirable. Okay, so this problem has to be handled, but the main problem is that if you want to use the TCP in ad hoc networks, so typically the network layer first what it does is, once a link is broken, one of the existing routes is broken due to maybe node mobility or something like that, it basically initiates the root, the network layer would initiate the root repair, and this root repair basically creates delay of acknowledgement arrival, and this delay is mistaken by the TCP sender, that means the transmitter, as a sign of network congestion, okay, and consequently the congestion control mechanisms are invoked by the transport layer, and because of this basically the communication throughput is going to go down drastically. So, this is the problem with using the traditional TCP, the TCP that was proposed for internet, for use in the internet. Using it for ad hoc networks is a big challenge. Okay, so there are different protocols. We'll talk about these protocols that perform better than the traditional TCP for use in ad hoc networks. TCP feedback is one, TCP bus is another one. There are many other different types of mechanisms that have been proposed for use transport for taking care of transport layer issues in ad hoc networks. So, here are some of the the references for the first two modules. So one can consult any of these different books. Some of these materials and the different concepts are borrowed from these books. So the first two modules, the references are given over here. Thank you.